All right, let's begin officially. Once again, welcome to the ROS Naija Meetup in Abuja. This is the first one for the year and the fifth of the series. I am Usman Ahmed and I'll be your host for the day. If by any chance you can't hear me properly, just let me know. I have a B-foot microphone, so we tend to fight a lot. It's a common thing for me. So we're all here because of ROS. We all love robotics, or we want to get into robotics, something similar. So what is ROS? That's the first question we should ask ourselves. The main thing that has brought us here. So does anyone care to tell us what he or she knows ROS as? What they understand as ROS? Anyone here? Thank you, thank you. He's a very brave man, and hopefully we'll have more brave men and ladies here.
So is it like the full meaning of ROS? That's Robot Operating System.
All right, thank you. ROS means Robot Operating System. But there's a caveat there. When you hear operating system, you might think of Windows, you might think of Ubuntu and Linux. ROS isn't a traditional operating system as such. It's a middleware. It sits on your operating system. That is one thing you need to know. So for you to use ROS, you need to have an OS. And most roboticists make use of Linux. But now you can use ROS on Windows and you can also use it on Macs. So that is what thing I want you to know. And ROS is a very huge community, you see. We have people that make use of ROS and contribute to ROS, researchers, roboticists, students all over the world. It's open source, so everyone can contribute their own projects. There are many ways you can contribute. You can add a package or even just work on the documentation for someone else's package that you've used. That's a way to contribute, and that's how the community grows. And our community is governed by Open Robotics. It's a non-profit group that oversees the development of ROS worldwide, everywhere. And there are a lot of platforms. If you want to really get engaged with ROS, there's a GitHub page. There are local platforms like WhatsApp groups, community groups. This is just one of those platforms, our own ROS Naija. It's one of those platforms where you can talk about ROS, share ideas, communicate, and collaborate. And there are a lot of events when it comes to ROS. There's ROSCon, that's like the global event for ROS. It's an annual event. Last year it was in Singapore, but this year it's going to be in Canada. And there's also a scholarship for people to attend. Everyone here can apply for it, but unfortunately this year's scholarship has, applications for it has closed. So just look out for next year's application. You can apply for it and hopefully you get it. But before then, I recommend you actually do something and share the things you've done in robotics. That gives you an edge in getting the scholarship. Next is industry adoption. A lot of companies actually make use of those. You can see Boston Dynamics. I'm sure you've seen their robots, the humanoid and the quadruped robots that they always display. You see those dancing robots. Some of them actually make use of those, but not for all the activities though. Then you have Robotniks, Amazon, Fetch, and Power Robotics. They all make use of ROS, so it's a very huge platform. Now that I've told you a little bit about ROS, I want to call on the brand manager of Innovate Hub, our sponsors for today. Without them, we might not have had this physical meetup. So please welcome on stage Christiana Ogaba to give us an opening address.
Good afternoon, ladies and gentlemen of ROS Naija community. Are you excited to be here? People don't sound excited, sorry. Anyways, good afternoon. Like you said, my name is Christiana Ogaba and I'm the brand manager, Innovate Hub. On behalf of the management of Innovate Hub, I would like to warmly welcome you to your first meetup here. I think it's, like you said, your first in Abuja, right? Yes. So, yeah, warmly welcome you. to our hub as well, Innovate Hub. I dare say one of the largest hub in the whole of West Africa. And we believe that today is not just a regular meetup. I would like to say that I believe that it's the beginning of something that has the potential to shape how innovation happens within the ecosystem. At Innovate Hub, our vision is quite clear. We have a vision to nurture the future of communities where communities drive innovation, not just the institutions, not isolated individuals, but the communities, people sharing knowledge, challenging ideas. Robotics and intelligence system is not something, it's not a concept that is really far away, like we talked about when we were very little. It is here and it is close. It is. We can continue now. Okay. It's not like a very distant concept anymore. It is here and we are experiencing a lot of things that are happening. It is refining industries from agriculture to healthcare, from manufacturing to even our everyday lives, right? But technology alone cannot create impact. Communities do that. Communities where learning becomes practical, where ideas are tested, where collaboration is replaced by competition, where innovation is sustainable, right? So I believe that this collaboration between Innovate Hub and the ROS Naija community is actually very, very intentional. It is not something that we're just doing just because we want to do, right? And we're not just providing you this space, we're actually supporting a movement, right? A movement of builders, a movement of engineers, developers, problem solvers who are willing to take on the challenge of actually building, experimenting, and challenging how do I put it? Experimenting and challenging the possibilities of actually things that we can build, right? So I want to urge all of us as we engage in today's session, don't just be a participant. Think contribution, think collaboration, and think impact, right? We are very, very proud to support you on this your journey. And we look forward to seeing the ideas, the projects, the innovation that would come out from communities like this. Once again, we want to welcome you again and have a wonderful session as you continue. Thank you.
Thank you very much for that, Christiana. And thank you to Innovate Hub for having us here and supporting our movement. And just a fun fact, if you see on my left there, we have a number of robots. So some of them were actually developed in Innovate Hub here. So you can see evidence of what they do and what they support. So we're very grateful to them. And hopefully at the end of this event, we'll be having some games with some of the robots. So please stick around. Don't rush to leave here. We want you here. And to those of us joining online, you are very much welcome to this session. We're glad that you could join us online, even though if you're not here in person. Now, let's talk about ROS Naija community. Why ROS Naija? What brought us all together? Every other aspect of life, you have to come together to actually move forward. It is a basic principle of life, and that's what we're doing too. So if you guys came together and thought, okay, we all love robotics, and how can we help ourselves? How can we get a body? People come together, share ideas, collaborate, and develop robotics in Nigeria, and that's how it came about. So we had the first ROS Naija meetup in 2024. That was in Lagos. Did anyone of you here attend that in Lagos? Okay, we'll go back to that. Yeah. Then we had 3 other sessions last year, 2025, and this is the first one in 2026. And this is the first time we're having it in Abuja again. I would like to repeat that because I'm really excited about it. I haven't been able to attend any of the sessions in person, but today I'm here. So I want you all to really participate, connect, network, talk to each other, see what you can do in the field of robotics, because I'm very much aware of some people that actually met from ROS Naija, and from there on they developed robots together. Some have even published papers in international journals. They've been accepted just from meeting each other here. And some have actually gone as far as developing their own robots for maybe their school projects, and that has led to them maybe going on to do their postgraduate degrees, getting scholarships, going out of Nigeria for that. So it's a very, take advantage of everything that this community brings to the table. We have a platform on LinkedIn, and I'm sure a lot of you got to know about this event from LinkedIn, right? So we have a Slack channel, we have a WhatsApp group, and we have a website too. So please make sure you have a look at our website. It's just Google ROS Naija on Google, and you see everything you need to know. Our website, from our website, you can get our Slack community and also our WhatsApp community. Now, without further ado, I would like to call on our first speaker for the day. His name is Timothy Kene Ukweze. He's the simulation lead at Innovate Hub, and if you ask him, he will tell you he's a robotics enthusiast and novice. But, you know, at the end of his presentation, you'll be able to judge that for yourselves. Let's give him a round of applause.
Okay. All right. So I'm going to. Okay, my name is Timothy Ukweze. Actually, it's Timothy Kene Ukweze. So for some reasons, I'm well known with with my middle name. I don't know who to blame, but it's okay. I'm going to be speaking on role of simulation in robotics. So we don't have like too much time, so I'm going to power through the slides and try to explain a whole lot of things. All right, and in a very high level way, but I still want it to be very interactive because it's supposed to be a meetup, not a conference. So we can talk together. There's a mic for anybody that wants to ask a question during the presentation. So you can interrupt me. You can raise your hand if you have like a. All right. If you have like a question or what have you, you can raise your hands. The mic will be passed to you. So we'll make it more interactive. All right. All right. So, robots and simulation. So first of all, let's define what a robot is. So by our own, in Innovate Hub, the way we know robots, or what we know robots to be is like any device or machine that we build that can do the foundational parameter, which is like sense, think, and act. That means the robot should be able to perceive its environment, internalize that data, and make decision based on the instruction that is given. So we also have simulation, which is not just tied to robotics alone. There's a lot of industry uses simulation. So from the automobile industry to construction to biology, like people in the medical field as well. So we use simulation to model, test, validate, and get results, right? So, but we're not talking about other kinds of simulation today. We're talking about robot simulations. And as you can see, we're going to be covering some of the experiments we've been doing in the hub. So just to give a brief bio, I'm currently leading a simulation lab in Innovate Hub. And most recently, we started getting serious with robotics. And prior to that, we've been experimenting. So while I'm talking about the role of robot simulation, I'll be sharing some of those experiments with you. All right. So learning robotics. This is a meme. I had to find it because when I first got it, I was like, this is perfect. So you see, this is the roadmap for almost every wannabe robotics engineer. when you want to learn, the standard is when you want to learn robotics, simulation is the easiest way to start. And when you start getting into mechanics and electronics, this happens. So because hardware is hard and software is even getting more soft because of AI. So we are at that era where most people do this. So how many of you are in this area now, right now? All right, don't worry. If you are in that part, don't worry. After this presentation, maybe probably you'll be going forward regardless of how difficult it is. So okay, moving on. So before I move on to that slide, so what I want to establish here is that it's pretty much easy to learn robotics using simulation. Why is that? Because one, in Nigeria today, I mean, it's even hard to get the hardware components. Maybe it's not about how hard the component is, but because of the time, the money to get it to practice. That's a problem, right? So, and this is the difficult. This is why some people actually turn. So you want to start with simulation. You don't have to wait for your hardware. You don't have to spend so much to. And you can actually start writing codes. And that's why also ROS exists, because you can actually use simulation to start learning ROS. We'll see that in a bit. Okay. All right. So let's say you've learned ROS or something like that. You want to build a robot. And this is me validating all the rules of simulation. So first of all, one of the benefits of using simulation is the fact that you're going to be able to validate your robot design. And I'm assuming that you've learned maybe how to build robots, or you've learned how to use ROS, understand the ecosystem a bit, right? What you want to do is to start building the robot, right? So, and the way you go is from CAD to what we call URDF, which is like a file format that represents the kinematic structure of your robot model. And from that, you can now get it into a simulator like we have here, Gazebo and Isaac Sim. So, and the fact is, when you're designing a robot, there are a lot of considerations, right? And some of them you might not even know until you've designed it or until you've tested it. So instead of just building the hardware and finding out late, you can actually validate that design in simulation. And I'll give an example. Right now, I don't know whether you are with me because I'll ask a question now. Who knows the difference between these two? Okay. Is there a mic or something? Okay, there's a mic here. No, that's it. Okay, that's what. Okay, just.
You mean between the softwares?
Yeah.
Okay, so Gazebo is the free.
Okay, just talk. Yeah.
So Gazebo is the free and open source simulator developed by Open Robotics that's packaged with most ROS installations, especially the ROS Visual, ROS UI. While Isaac Sim is NVIDIA's simulation cloud environment that has its app, but it's better served on the cloud because that's where you can get it.
All right, so they're both simulators. So, right, so I just wanted to clear that confusion. So these are two simulators. So we just tested importing our robot model into both of them separately. So there's nothing linking them. So he described it very well. So Gazebo actually is maintained by Open Robotics, which is the company that maintains ROS. So Isaac Sim was developed by NVIDIA, because now it's actually open source right now. So yeah, so going back to what I was saying, so you get to validate the basic mechanics of the system. For instance, if you are used to designing this kind of robots where there's like the drivable wheels are in the middle, you see one of the things that you find out is that if those caster wheels are not like spring loaded and they are very static, when you have like a bomb, you have those drivable wheels on the air and the robot will not move. So we were able to, you were able to find out some things like basic mechanics like this in simulation, because you will have to start adjusting them, and that will make you adjust your design. So this was a basic example. I'm going to give you also another scenario. So this is another robot we were trying to design, similar but bigger, right? So if you can see the older design, that was before simulation. The older design had that one caster wheel at the middle, but you find out when you're scaling that, like you're scaling to this kind of platform and the size and everything, you find out that you have instability in the whole system. Now you can actually, maybe as a good designer, you might intuitively know, right? But you can actually validate this in Gazebo. We actually did. Because when we tried simulating having this in the Gazebo, we started noticing this wobble, right? Showing us, oh, this is very unstable. So that's why we went for a design where we have like 4 caster wheels and stuff. So let's think about this. Like maybe you were going to buy your components before you do this. You've already selected 2 casters, right? You've already made a mistake. That means like waiting for another 2 weeks if you're ordering it from outside, or maybe that specific size and stuff like that. So that's why for us in this part of the world, we need to also actually be critical about the way we design, right? And we need to use the simulation first approach. Okay, I'm not doing this fast enough, but it's okay. So I really wanted to show this video because it was an animation made by my team. So we're introducing our robot that we designed specifically for office service activities. It's going to be like a research platform, right? Having different things that we're going to be testing, scenarios and stuff, what have you. It's going to do catering, what we call it, patrolling, what have you, like any function we can get out of it for indoor services. So you can have different modules for the payload. Okay, so now, when you've built your model, robots are meant to interact with the real world. I mean, they're supposed to function in the real world, right? So in simulation, you can actually create that world, right? And test those scenarios. And that means you are not still limited by the physical, like you can actually go and explore. So, and that next stage is where you actually start looking at world building in your simulation. And this is one of the roles that simulation plays, which is where you can actually test all the interactions that you want to see in the real world. And this can also help you inform you in a lot of ways, like the sensor choice, height, position, what have you, because you need to validate all those things. I mean, you can do it while you're buying your component, but I think even simulating up to this extent might help you make better choices on the kind of components to get. Even the FOV and all of the cameras are important to your scenarios. So something like this is, okay, now I'll tell you the story of how we got this to work. So now, we like having things that are very visually appealing. So that's why we chose Isaac Sim. As opposed to, we use Gazebo and Isaac Sim for different purposes, but we're looking at moving into a more AI-driven workflow, AI-driven robotics and stuff. So for this project, we took an environment asset, which we created for a previs for modeling our space. So we have that like as a VR walkthrough, right? And it was built in Unreal Engine. So, and we were able to bring that into Isaac Sim as USD. USD is a format upon which Isaac Sim is built on top. So it's, I think you can do more checks around it. It's a very, very good format, an open source format. We also got our robot assets, which we've already prepared, as you have seen. Then we were able to bring them together. Then this is where also ROS is still important. I mean, you can use Gazebo for this, and you're running everything. You're building with ROS already in mind. So, but when you're using like Isaac Sim, you can actually build without it and build. Then now like use it for the communication layers. So, and this is also to tell you ROS is very important, and because it helps you. That, the reason why they call it a plumbing system is because it actually helps you connect all the parts of your systems together. So it creates that network for you easily. So that's why even if you're using Isaac Sim, most likely you have to use ROS to do your communication. So for control and everything, we use the ROS. And so we'll move on to the next. Yeah, all right. For word building, there are multiple ways. I mean, you saw one way, which is like using already built assets for different use cases. I mean, you can model it by hand. You can actually use already made assets for different purposes and repurpose it for robot simulation. But a new trend that is coming out is using 3D which is Gaussian splatting, 3D Gaussian splatting. It's a neural 3D reconstruction method, and this can quickly get you from taking pictures and scanning your environment and bringing it into simulation real quick. So this actually opens the door to many things, because before we have to like handcraft environments, assets, and stuff like that. With this, you can actually scan and get 3D working, your world working. While it's still in the early stage, there's a lot of experiments with regards to physics, lighting, and what have you. It's really, people are trying to see how they can utilize this method, because you want to be fast in your iteration cycle. And you can even get to the, okay, yeah. Yeah, so like actually, yeah, you can. So it depends on your inputs. The result you're going to get is depending on your input. So if your camera is like bad, you might not get a very good result, but you might get something ideal. So depending on your use case for Gaussian splatting, you will choose what device to use to capture. Right, you can use your iPhone, you can use a tab, you can use specific, there are 360 cameras that you can use. You can use high resolution cameras and stuff. Then there are specific cameras that have been built for 3D Gaussian that you can actually get if you are feeling so rich. So, yeah. What's that? Yeah, okay, for this one we used an iPad Pro, yeah, to capture this. It was just a quick test. And these are like spaces that exist in this hub. So the other one you saw was a cafeteria, while the other one was like one of our main spaces. It used to be like the drone area, but it's okay. Well, yeah, that's basically it. There was a point I want to make, but I think it's okay. We can just move on. Maybe if I remember, I will also talk about it. So yeah. So another use case, simulation, there's this AI trend, or will I say hype, and but there are uses we've found use for AI in robotics, right? And we are seeing how it is actually enabling a lot of things from perception to motion and all whatnot. So you can see here synthetic data generation, where you can actually maximize data collection in simulation. Normally, gathering this data in the real world will take you time, right? So, but now you can actually generate this. You can create this simulated data. Annotate? Is that the word? Yeah. So, yeah. So you can actually start getting your data set, training on those data that you've gotten from the simulated world. You can even combine it with real world data, and maximize the efficiency. So this has allowed us to scale AI training. So we also have for motion, where we talk about imitation learning, reinforcement learning, and all that stuff. So you can see some works that are being done over there. So with this, you can actually scale training. Like you can see this humanoid robot that has multiple instances of it in training and simulation. This is how we scale. So something that would take like 1 billion years if you were testing with hardware, it will take you like an hour using this this framework. This is what simulation is doing in robotics today. So AI has made simulation more important. So if you're going to you're going to build an AI robot, most likely you're going to be using a simulator to train your models. Like I've not heard anybody that say that they don't use simulation to train AI for robots, right? I've never heard. I mean, there's a simulation, a sim to rig gap, right, where transferring all that learning to the robot is not so easy, because in as much as we can get enough of the physics and stuff, but we cannot really ideally recreate real-world physics, because there are a lot of things that the fact that the imperfection of the world, the imperfection of sensors and all those things cannot be really created perfectly in simulation. So that's where the gap exists, right? And okay, all right, and we're trying, but if you look at the research papers and stuff, everybody's trying to actually bridge this gap using different strategies and methods. I will move on before I think I've exhausted a lot of time here. So we move. So yeah, so in case you want to like start AI robotics, this is also a very simple platform to use. We have a setup here. It's called the SOARM 101. It's actually, it was built by Lee Robots, by Hugging Face company, because they have this Lee Robot platform for, all. Okay, so they have this Lee Robot platform for AI robotics. So you can go there and use their open source tools and start working with them. So this is a platform where you can actually start learning simple AI robotics, and it's very, very good. So we are actually exploring things using this as well. So you can do imitation learning, reinforcement learning, and all that stuff. So yeah, deployment, sim and real. So you cannot be a perfect roboticist without having to deal with the real world, all right? So you need to deploy, right? You need to be like these guys. So you need to be like these guys that we keep going towards the hard problems to solve this. So how many of you are willing to take this leap of faith? All right. Anyway, so deployment, sim and real. Okay. So there are ways to deploy, right? And you want to keep having your simulation in the loop as well, like for um, like multiple testing and all or whatnot. So like for instance, this was like when I was trying to get into ROS 2, I built like a platform for my own development, which I suggest that everybody should do. You should not waste time taking too much tutorials. I mean, you should have a plan for projects you want to do and start working on towards it. Build something, maybe a miniature size or something like that. So now, ROS allows you to like, there's this thing called ROS to control, which is like a package for interfacing and controlling your actuators and a whole lot of stuff. So it offers this ability for you to have this two-way communication for your simulators and and your real robots. So you can easily test your code or your ROS code or what have you, then test that in simulation. If it works, then you deploy to the real to test as well. So this is basically how this was actually done. So the deployment, you should always have that have in mind that building in simulation, your end goal is to build in the real world as well. So okay, I'll take. There's a question on the Zoom chat. Say, please, what is the headset and controller for in the 3DGS sector? So just like any virtual world that you have, virtual reality is just a way to be fully immersed in a virtual world. So we just used it to, because 3DGS can be very lightweight for VR exploration. So we just tested that basically in that demo. That was just a test for immersion. That was all. Nothing to it. No robotic stuff. So right. So we have okay. This is supposed to be simulators, as opposed to be simulation. So that's supposed to be simulators. So there are a lot of simulators out there for robot simulators actually out there for different use cases. So some people say, oh, the general talk is like, there's no perfect simulator that can do everything. Like, you need to choose based on on what you actually want to do, and at the game and your resources at hand, because you cannot be using Isaac Sim where you have like a 2 gig RAM laptop. You won't even work. You don't have a dedicated GPU and all those stuff. So you need to look at your resources and look at the ones that fit. So you can check the QR code. I would have written a caption on that, it was Russian. This links you to a GitHub repo where I think it was Kimberly from the ROS community. She put together a list of simulators that you can check and read about. You can find out their strengths and weaknesses and stuff like that. So I'll also drop that on the group. Okay. So honorable mention, because I'm running late, there's software in the loop, hardware in the loop. You need to just check these out. You can just take a picture, then just read up on them. There's sim to real. We talked about the sim to real gap. I think I'm hearing also there's real to sim. I mean, there's world models, that's AI world models like Genie by Google, and there's Word Labs and all those things where AI generate words, basically interactable words. There's a concept known as, it's a strategy actually in learning, domain randomization, where they create this is a strategy used to randomize the data sets, change lighting, the angle of components, and what have you. There's neural simulation. This is also a new concept I heard this year. It's a way to, instead of just do physics training, AI training, they kind of they generate this kind of video of the robot doing something, and the robot will think he has the ability to do those things. So it's more like dream. They call it dream. I don't know. So that's like the basic way I can explain it. So they create like these dream-like videos that make the robot look like he has actually accomplished that task before. So and the robot goes ahead to try it and do it. So all right. I think we are almost at the end. Okay, sorry. So now, summary, we've seen the role of simulation in multiple areas, and design evaluation, testing as virtual world interactions, where all your scenarios, behaviors, what have you. Then we talked about synthetic data generation, which is SDG, and ML, machine learning, and stuff like that. So deployment as well, talked about that. And you can see how important simulation is and the role of simulation is in the world of robotics even today. So that is the end of my presentation. Thank you. So are there any questions or should I ask? Okay. All right.
I wanted to ask, because you showed a scene with a lot of robots, many.
Yeah.
So, have you done anything related to the genetic design of robots?
Genetic design of robots.
Say you have, it's also similar to that improvement you showed with the simulation. So you have multiple designs, and then you have them complete genetically. Have you done anything? GA. Okay, sorry. I said, have you done anything related to genetic design of robots? Because you showed an old and a new, a slide about that for a robot that you designed in-house, as well as another simulation where there were billions of robots working and interacting together. So has there been any work done here on that field?
Okay, you mean AI learning or just the design?
Both in any sense.
Okay, if it's AI, we've not like really done specific projects in AI really that looks like that. We are still using, for now, we're exploring these arms for AI training. Then also the workflows, most of them are basically they are basic at this point. So we want to like flesh out how to actually build the workflows as well. Then I think we'll get to that point where we will actually have all those. Okay, I think what you saw was a parallelism. Is that what they call it? Parallelism of AI. So where you can have multiple instances of the robot training alongside and having like a central hub that they're communicating with. So we've read about it, but this is also things that we want to do going forward. Yeah. So any, okay.
All right, thank you very much for the presentation.
Okay.
I want to ask, among the simulations you listed out, I know you said go and read on them, but I've been having challenges when it comes to projects that has to do with constructions or agriculture. Let me say it has to do with the robot acting on a physical object.
Okay.
So do you have any, let me say, recommendation when it comes to such simulations?
Construction and agriculture.
Yeah.
So it depends on those domains, and especially what you are doing in agriculture.
Okay.
Let's say.
Let me give an example. For instance, in land preparation in agriculture, where the robot have to act like, let me say, it has an implement attached to it, which has to do with breaking the soil.
Okay.
So is there any simulation that can do such
breaking this? Of course.
That can show such
fidelity or physics fidelity.
Actions, yeah.
Let's say right now they actually, let's say it's an experimental thing for the industry as well. Okay. Like getting all these very realistic physics high fidelity simulations as well. There's if you, maybe you need to check Newton. There's a open source physics engine that is being built for robotics training and all that stuff. So it has all these high fidelity simulation for fluids, gravels, whatever you want to simulate. So, but I think it's going to be, I don't know, resource intensive. Yeah. So, really look at that and see how far you can go with that, because you might need a very beefy PC, to do that. Also, there, I think this also might be too expensive as well, because there are cloud options for using simulators on the cloud, right? Okay. But it's also cloud-based, so there's internet and stuff, and also you have to pay for like the credits and stuff. So let's say we've not got to that where we have like perfect simulations of robots, but there are things that exist that you can actually start exploring and get to know about.
Okay. Second question. Okay. You talked about deployment. Okay. That is in the area of moving from just simulation to the real world. Yeah. So can you talk more about how you deploy after running your tests, seeing everything in the simulation, and then you are going to the real world? Can you just explain your process? Okay,
so why my topic is like role of simulation, so I didn't want to delve into hardware too much, because we have Samuel for that. He has a session where he's going to walk you through the process of designing, even doing the simulations, a hands-on section. So he's going to also show you how to also deploy to hardware as well. So it's going to be more interactive, better than any answer I'm going to give you. Yeah.
All right, thank you.
Thank you. Thank you.
Okay, good morning.
All right.
My question is, you mentioned AI, like the bridge, how AI help in synthetic data. Yeah. Can you please ponder more on how you showed like the various robotics simulation generate synthetic data and help to create robot policy? So can you please ponder more on how we can actually use AI to train, like for example, using self-driving car as a definitely deploying those robots or those vehicles on the road are risky. So how will simulation help bridge that gap?
Okay, risky. But talk about the risk first, so I can know where to answer. Talk about what you mean by it's risky.
Okay, I mean, having to create your policies and just deploy these robot vehicles on the road because of damage to life and everything.
Okay, you want me to speak on the advantage of simulation for
basically on AI training.
Okay. I think I've mentioned it, but it's like what I said is one of the major things is scaling your training, right? The fact that why you don't want is also the cost of your robots. You don't want to train and fail. If you, like you said, there are risks. The risks are not just it's not just injuring somebody or something, but it's also the platform that you're going to be using, right? It might fail, it might damage, and it might be very expensive. So what you want to do is not train first on the hardware. You want to train on simulation. Then when you have something good enough, you can easily start testing gradually. So robots might still break, but it will save you a whole lot and also the time for training. Training in the real world will take you more time, like I already emphasized on. And you can scale that up very quickly with simulation. Like I say, 1,000s, right? So, and even though there is a sim to rig gap, you can actually merge that with a bit of real-world data and training as well. So this is also one of the strategies that they use to bridge the gap. Basically, I don't know whether I answered your question. Yeah. All right.
Do we have more questions?
I think even if you have more questions, just drop it on the. I think the time is.
All right. Thank you very much, Kene. Yeah. For those of you that have put questions on the Zoom, we've seen your questions, and some of them will be answered in the next session. Then we can see there's also one from DRC that has joined this session via Zoom. It's nice to have you here. Wow, so that was really interesting, Kenneth. Thank you very much for that. Let's give him a round of applause. While he was talking about giving us his presentation, I remembered an experience I had. I ordered some items that were to be shipped from Nairobi to Abuja, and they were sent to Abidjan instead of Abuja, and it took me 8 months to get those things from Abidjan back to Abuja here. So imagine if I was working on a robotics project, if I could work on simulations, I would have still gone very far, but that put a pause on what I was working on. That was a very terrible experience. So simulations are very important. Work on them, and remember there's always a reality gap. The gap between the real world and the simulations, so always account for that. And at the end of your simulation, just do it. Build your robot, test it out, work on it. That's when you actually get the real experience. Like hardware is, you learn a lot, don't worry. You'll be humbled by it and you would grow from it. So just make sure you do something. Then I would like to call on our next speaker in person of Samuel Obiagwa. He's a robotics controller and navigation engineer. He's very passionate about advanced robotics education. He's also a co-coordinator of the ROS Naija community. And finally, he's the CEO of RoboCreate. He owns a robotics startup. I'm sure you can see the banner behind me. He's the man behind it. So let's give him a round of applause. Thank you.
Good afternoon, everyone. Yeah, my name is Sam. My name is Samuel. And I'll be sharing my screen actually because this will be also, we have a little workshop and a little demo in this session. So I'll be sharing my screen. I don't know if still, I don't know. Mine's, wow. Okay. Yeah, so good afternoon once again. It's quite slow. My network is quite slow. My name, but I'll be reading from here, so hopefully it picks up. Yeah. My name is Samuel Obiagba once again. I build robots. So anyone that knows this, I just build robots. I just have to touch something. I just build robots. That's the best way I can describe myself. I have to do this again. Shame. Okay. So like I said, I'm the CEO of RoboCreate, the developer of MobileBot. It's an educational robot built in ROS, and it's over there. I'm also a ROS control and navigation engineer. Actually, I'm into control designs and navigation. Those are my core areas, and I'm passionate about practical, advanced robotic education because I'm very obsessed with control and precision, actually. Yes, and I'm also one of the ROS Naija community coordinator. And really, this is what I say. I don't think robotics should be intimidating. We see a lot of things on LinkedIn. We see those robot tests and things like that. It should not be intimidating. So, but I know that with the right tools, with the right guidance, I think these things are possible because I also tried it out. And be able to achieve something. And like I said, RoboCreate is an educational initiative, and we aim at actually advanced practical robotics innovation using ROS. We also use other frameworks, but ROS is one of our core frameworks, and we build robot platform. Okay, so I'll just continue. So just follow me. So, like I said, we build at RoboCreate, we build hardwares. We also develop softwares that helps people to build what? To build robots. And we also develop embedded control systems, and practical learning tools for robotics engineer. We actually have some of our products that we have developed. And we have the robot platform, that's MobileBot, an educational robot built with ROS. We also have a kind of motor controller module. One of the problems in robotics is, something motor control. If you have ever tried, and if you try integrating control into robots, that's where you actually get stuck. We developed a motor controller module that's a PID control for precise speed control, and it's what the MobileBot is actually using. You are going to see the old test, and it works with geared motors that uses quadrature encoders. I know you have seen motors like that in the past. So, okay. No problem. So most likely I'm going to be saying a lot of things with my mouth. Yeah. So, but before I continue, I don't know if we got an email. I noticed most people are not with their laptop. We got an email for a particular setup. Just want to do a little workshop. Anybody tried setting up? Just copy and paste. No, there's no issue with it. Okay, nobody? Okay, you tried it. You can bring it out. So when time comes, you can. So basically, I'm just going to be talking about navigation, ROS2 navigation, actually. ROS and ROS2 navigation. And navigation is, we have seen autonomous cars, moving in streets and things like that. I know we all have examples of these different cars that maybe we have seen. So navigation is actually very important, and I want to talk about it, and I also want to talk about what ROS2. As we have gotten earlier, ROS is a framework for that makes building robots easier. That's just the truth. I know we're all familiar with Arduino. If you have not used Arduino before, raise up your hand. Okay. Well, just as Arduino is to the electronics world, that's how ROS is to the robotics world. You understand what I'm saying? Arduino made it easy for a lot of people to get into embedded system easily, and provided a platform, a standardized way of programming what a lot of all these are controls. Yes or no? That's exactly how ROS is. Robotics is actually building a robot is complicated. That's the truth. And I know that most of us in the past Or if you were to build a project now, I want to just ask, if you are building a project, normally your workflow might be like you write all your code. You write one single code, yes or no? If you have not done it before. If you have done it before, raise up your hand. You write once, even if it's Python, you write everything. You write your camera code. Inside that same place, you write your what? The one that will control your motor or your servo motor. Have you? You read ultrasonic sensor also from that same node. You understand now? In real life, don't try to. Please. and that's one of the beauty of what? Of ROS. So ROS provide a kind of platform. Sorry, let me share. So ROS provide that platform or the framework for what? For building what this robotics systems. It makes it easy. So there's that you can now write your camera code separately. You can write your motor control code separately. You can write different part of your robot's projects separately. And all of them will be able to communicate with each other. So even if one part fails, your whole system does not fail. You understand what I'm saying? So that's really that's like on a basic level, that's what ROS does. Although my screen is being shared now, I don't know why it's not. If you can, I think, let me ask them, they can get the link. The link is on the workshop. They just display it, if that will work. Do you understand? The workshop, the presentation link is just use it. So, and on the, if you are with the, if you have the workshop link with you, please you can just open it. You see the presentation link there. Just click on it. So you can follow easily. Do you understand? If you have the workshop link, there's a link that was sent. The workshop link. Go to the GitHub page. You see the presentation link. Just click on it. Have you tried it? You can try it out here, so you can easily follow. Also, why? Okay. Thank you very much. The next slide. So these are some of the products I was talking about. That's the motor controller, the PID motor controller for precise control. And we also have an easy IMU, which is a 9-axis IMU that provides filtered orientation reading and accelerometer, filtered acceleration data, for your project, and it easily integrates with ROS, with Arduino. Talk about it with Python, with C++. Just integrate it and start using. So those easy calibration and all those things. So and that's why it was designed. Next slide. Can I control from here? Okay. So thank you very much. So basically, the objective, like I said, is just to understand, give an idea of ROS, core of mobile robot navigation, and also we want to introduce us to what they call the nav2 stack. It works under the hood with ROS2 and is used for autonomous navigation, and we also run simulation tests with mobile bots, and also we do a real life example of what I'm saying with the actual robot. Okay, so I think I've already introduced ROS. I've showed you have different code. You have your planning code, your localization code, navigation, your control. You can have your camera code, your control code. You now have a separate code again for visualizing. So all these things are just working together, and you see they are just communicating together. You can see the highway. So each part are just communicating together. That's the beauty of ROS. And if you are coming from an Arduino point, you will notice that there's a lot of life. If you want to start using servo motor now, you don't have to know how to program servo motor from scratch. You don't have to know. You just download the library and you start command yes or no. That's exactly how ROS is also. So imagine you want to start writing algorithm for a lot of all these robot control and navigation. It can take you months or even a year. And I'm being serious. Yes, I've tried one before in my lifetime. So if you are not, it can take you very long. But and that's why it's also a community thing. A lot of people have worked on different kind of algorithms. You understand now? They release it to the ROS community, and you can just pick it up, understand understand the different ROS messages, and use it in your project. Do you understand that? So that's also what ROS offers. So it makes your robot building modular and scalable. So, and that's one. And these are just the basics of ROS. I might not go too deep because of time. Just the node is your program, like your Inno file, your Arduino Inno file, your topic. For those that have done serial communication before in Arduino, you send message over with serial data. Yes. So ROS has something like that, but now there are different type of data. There are type of data for LiDARs, for controllers, like that. So it makes it easy. So even if I share my code to you, you kind of know what you are looking for. Okay, if you need my camera data, you already know the kind of data you are looking for. So it makes robotics, that's why companies are now adopting it actually. Do you understand now? And even research, students, they are adopting it. And that's why we are also seeing how we can start adopting it. Because if we are going to go far in robotics, do you understand now? I almost said praise the Lord. If you are going to go fast in robotics, you understand? You have to start learning these frameworks, because one of the things they help you do is to learn a lot of all these things quickly and easily. If you now decide that you want to now write your own from scratch, good for you. The Lord help you. So the next part, and if you have the moderator already make us understand that, it comes in different versions. It's like an operating system, but not an operating system. So for those that have used Ubuntu before, how many of you let me ask, how many of you have used Ubuntu here? Ubuntu, Linux, okay. Thank God. Thank God, thank God, thank God. And even if you are on Windows also, Windows 11, Windows 10, and things like that, Ubuntu 22.04, Ubuntu 24.04, that's exactly how ROS is. You can see the one I'm circling is what? Jazzy Jalisco. Yes, this is a long-term version. So for those that are from Ubuntu who understand some of all these things, this is a long-term version. It will be, the end of life is May 2029. So anyone that is getting into ROS now, please just go with Jazzy, ROS Jazzy. Do you understand what I'm saying? It's long-term and it's ending May 2029. Do you understand now? So that's what I'm saying. So you can read more on the slide. And this is just I know someone asked the question on the chat, how to get into ROS quickly. So I put a kind of structured way. You must try and you understand Linux, have knowledge of Python. If you like, add knowledge of C++, then learn some of those fundamentals of ROS. Then there's a series from Automatic Addison. You can check this series out. It's very, very, very good. You just learn all this. It's on the slide. You can click the link and you understand now. Just go to any of the link. Do you understand now? So this will help you out. For those that want to get into ROS, just follow the link. And once you learn it, start on the community group and start trying projects. I'm going to show you an example. There's a project I did as a research assistant at Federal University of Ekiti using ROS by just knowing just the basics. Do you understand? So it's possible. That's what I'm saying. Okay, so now to robot navigation. Yeah, so I know maybe, what navigation just simply means, you're just trying to move your robot. I'm going to be using mobile robots for now, from a point to another. You understand? And in the process, you probably will avoid obstacles. We're going to see everything today. And to try to follow the shortest path, do you understand? And try to reach the goal, note the word, autonomously by itself. That's it. By its what? By itself. So you understand now? So there are different concepts like localization. Where is the robot located? Do you understand now? For example, let's do a kind of 2D mapping of this place now. This is our 0, 0 point. Do you understand what I'm saying? That is point 0, 0. Can you draw the graph now? Point 0, 0.
X and Y, your X and your Y axis.
Just draw it anyhow. You understand what I'm saying? So probably she's at point 2 and 3. You understand? 2 meters from the x-axis. Do you understand now? So that's 2 and 3 is what is called localization. So how can you know where the robot is? Do you understand now? You two are at a particular point. That's what is called localization. Do you understand now? But not just 2 and 3, but what also where it is, where she's facing. She's facing this way, Abby. So these are the information that what the localization was capture. Where is the robot located within that what a particular what environment, and the goalpost is what where is the robot going, and what also how to get there. That's where things like you are planning the path, and you also what be following the path what to avoid us to get to the goal. So then I left some resources. You can check it out. Very, very good resources. One from Brian Douglas, and just check them out. Yeah. So now navigation 2. If you remember earlier, I told you that ROS has what libraries, or what you call frameworks, group of libraries, frameworks that makes a lot of all this your project building what easier and faster. Just like you have several libraries. So this is a framework for robot navigation in ROS 2. You understand now? So it has all the things you need, from mapping to localization to path planning to path tracking. Which other thing again did they doing? Just talk about it. It has its docking. Do you understand now? SLAM. How many of you have heard of SLAM before? Have you heard of SLAM before? Good. So it has all those things. So it does. So it's just for you to, what you usually requires the setup, then tuning. Do you understand? Setup, test, tune. Do you understand? So that's the ROS 2 navigation stack. Okay, I think this is the. Okay, so now these are just example of 2D robot navigation in real world, and these are things I have tried. These are 2 projects I have worked on. This was now by my right. Sorry, by my right. That is this. Sorry, I don't know. It's a bit dark. So if you notice, we are used to line following robots now, Abi. So I want to use this to explain before going to this. We are used to line following robot. Now this is point A, B, C, D, E. So I'm telling the robot, move to point E. Do you understand now? So the robot knows currently is at point A. So who can tell me where the robot is now? It's between where? Yes. Do you understand? What is he doing there? What is he doing there? The word. Thank you very much. Localize what? Localization. So it knows, I'm between point A and B. Now I'm at point B. Yes, I'm between point B and C. Now I'm what? Point C. And you can see now that the map is, for a line following, you develop the map yourself. It is what you put there. That's what the robot knows. Do you understand now? And it can follow the path. You write your line following algorithm. Now it works with a directional algorithm that plans such as paths. So it uses directional algorithm to know where to go, the shortest path to go from node to node. Do you understand now? So this is like a much simpler way of navigation, but this is where we are going to. This is both was done with what? With ROS. That's what I want you to understand. Now this is where we are going, the autonomous mobile robot using what? Nav2 stack. Now you can see now we are looking at, this is called an occupancy grid. What you see here is an occupancy grid, a 2D representation of your what? Of your world using what? Grid cell. Okay, no problem. I'll round off now. Yes. A 2D representation using what? Grid cells. And you can see, like I explained, localization. It knows the point X, Y, and theta. Theta is what? The orientation. I told you how the robot is. It knows those points. That's one. It knows the point. It's also able to avoid obstacle, creating the map and navigating. So this is like the concept of robot navigation. Now, if you try to do this and want to write your code yourself from scratch, like I said, it is you and God. And that's the beauty of using what? ROS. And so that's the basic navigation flow. Yeah, and this is an high level. Navigation is wide, is deep, wide, depth. Just talk about it. But this is just the basic. It's the help of Nav2. You can start by can easily do what you call mapping. You create your map. Then you can also, during the process of creating, you can navigate while mapping, save the map as occupancy grid or post graph for those that are doing SLAM. Then you can start navigation, test your localization quickly, and then run the navigation, plan path, avoid obstacle, move the robot autonomously, and finally you might need to tune the parameters based on your specific robot, the shape and its behavior that you expect from it. Do you understand that? So that's just the basic idea of navigation. Because of time, we won't be able to go too deep. And quickly, we'll just be doing quick tests with the robot. Now, this is MobileBot, a ROS2-powered mobile robot that was developed at RoboCreate. Have any of you heard of TurtleBot? Ross, if you have heard of TurtleBot, just raise up your hand. TurtleBot, okay, 1, 2, 3. Okay. So this is a Nigerian TurtleBot. Do you understand that? That's what I'm saying. Yeah, so this is the Nigerian TurtleBot. So it's for autonomous navigation, and actually people are using it. Actually, it's getting yes, it's open source. It's open source. The code is open. You can get the code, use it, and you understand that people are using it. Not just Nigeria, but even outside Nigeria. Do you understand now? So it's used for quick prototyping, testing, what I believe is that if you can use this, you can build your own mobile robot. And I have people who have even used it here in Abuja. Do you understand now? To build their mobile robots, and they are using it for their thesis. Yeah, thank you. So, and it's built for students, researchers, schools, integrators, labs, whatever. And, it talks about simulation and real-world deployment. And the idea was to kind of reduce that gap, between you simulate and see what you are doing in real life. So that's just how it is designed. And it also comes with a mini version. It supports live coding with block-based for people that want to do something much simpler, block-based programming, or you also want to do Python, C++, and even some basic ROS too with ESP32. The normal one uses Raspberry Pi. Do you understand that? So now, think to the workshop. We have loved to simulate, but now that I'm having issues connecting, I might just have to go straight to to the actual test. Is that okay? Thank you. I think I'm still on the network. Sorry to our online brethren at this point in time. I don't know how to, I'm trying to push this out, but let me. If you can't connect. Yeah. Look at my USB. Yes. Okay, so we just want to do a quick test and a quick workshop, and we sent some. That's why we sent that particular link out. So I don't know. Did anybody even try? Did you get the link? Did you try it? Nobody tried it. Nobody. You didn't get the link? Around 25th. How do you know if it's good? Let me just check. And it should not affect this. Okay. I'll just do it physical. I want to see if I can make it. I should just do physical now. No problem. Okay, so. Okay, no problem. You can just drop it on the ground and on it. Just drop it here. So just to give you an idea, if you notice, this is a 2D LiDAR, has a camera, there's a grip pad, there's a new feature. It also uses the EPMC motor control, like I told you, a precise motor controller, and then it has its power pack. And I'm going to doing some navigation tests just to explain what some of the things I've been blabbing about. So I'll see if I can connect, and I don't know, I'm going to show you. Okay, good. We are connected. I'm trying to connect to the robot. I'm going to show this. And there's no like HDMI. They can get HDMI. Maybe I won't. Let me exit there. Okay. Please open. Please open. Please open. Okay. So I want to start by, I would have loved that we could at least see the screen, if at all. Just the screen. Very, very important for visualization. Okay, I'll do my best. So first and foremost, I'm connecting with the robot and with ROS currently. If you are with the workshop link, you see a part I put do not run. If you notice the do not run the part 2 of it. Yeah, so that's where I am. We are meant to do that, do all of it here. So, well, I'm currently connected to the robot. Let me. So I'm just going to go straight to the navigation and mapping. So quickly, I want to map the robot. I want to map this environment. Do you understand? And that's the beauty of ROS. So I've started it. Let me just open the visualization. Good. I don't know how I'm going to do this, but if you notice something, you will notice that there is a map of the hall. You can notice that the robot itself, do you understand now? It's creating a map of the hall. I wish you could. It's creating a map of the hall currently. So this is the mapping. It's currently trying to map. So basically what I'm going to do, I'm going to send it to any, I want you to choose anywhere you think I can send it to, whether that's this point or, no, it can't climb, it's just a planar road. Okay. Okay, let's just, so currently, if you notice, it keeps, as it's moving, it keeps building the map. It's building the map of the environment as it keeps building. So if you have even the simulation there, you can start testing what I'm saying now. Do you understand now? The do not run 1, that is for the simulation. Do not run 2 is for the hardware. Do you understand now? So I'm going to send it towards the end here and let it face me. It's going to go towards the end here and face me. So as it's doing so, it's building the map, continuously building the map. You can see it. Yeah, and it's noticing the different chairs. So you can take it out. It's noticing the chairs and all those different parts. So, and this is one of the beauty of. Yeah, so yeah, thank you very much. So I just want to send it towards that end. Do you understand now? Once I do it, please over here of me, move it around a bit. And that's the beauty of ROS 2 and also an hardware like this, because now you have a way of running your tests, mapping environment, and tuning based on what? On your use. For example, there is someone currently, I think he's here, he's a moderator, was working on his master's thesis. He needed to do some navigation and things like that. The world has gone away from obstacle avoidance, ultrasound. I hope you're aware of that. You understand what I'm saying now? And the world has gone away from that era. And that's why we're also introducing ROS to you guys. You actually have to stand in its way completely. It's better you stand in its way completely. Exactly. Because of the LiDAR. Do you understand now? Thank you. You can stand at its front anytime. So what we are saying is this, that while we are advocating for ROS is that the world has gone beyond just normal Arduino and all those things. So it's time to start exploring simulations and real hardwares. Do you understand now? I'm building something, because I think when I went to Singapore, I had the opportunity to attend the ROSCon Singapore last year. I also made a presentation of this in one of the lightning talks at the ROSCon. You can check. I'm online for that. So, one of the things you will notice that there's a lot of all these things out there. I went to the airport, you see robots autonomously moving. And if we don't start getting into this early, you understand now, we'll be left behind. Beyond simulation, what we are here to tell you is that ROS offers you what? Go into simulation and test your ideas. And you can also what? Do it also what? In real life. That's the summary of the meetup today. Do you understand now? And we are trying to see that we have that ecosystem where people can what? Learn these things, both from simulation what? To real, and start what? Developing autonomous robots, at least to solve a lot of our problems, navigation, and the likes. Do you understand what I'm saying? And all these things is made possible with what? With the robot operating system what? Framework. You can start trying it for your final year project. Use it. Tinker with it. You understand? It's fun. I think that I would have loved to do quite some things, but I think because of time, I might just have to stop here. I wish you could see a lot of the things, the visualization, because I wanted you to see the visualization of the mapping, the localization, the path planning. It kept planning paths. That green line that you keep seeing, it's planning the plan, avoiding obstacles, and all these were possible with the navigation to stack. Do you understand now? It's already prepared. It's just for you to now start using it. And even if there are frameworks also for, I think there are framework data sets for those that are even interested in normal autonomous driving for actual cars. Do you understand what I'm saying? ROS has a framework for that data set and things you can start playing. But that one with simulation, like you explained earlier, you know that you have to have good laptops. Do you understand what I'm saying? And so that's just. So I'm going to just bring it back to me so that it doesn't run away. Do you understand now? Yeah. can pass it around. This is the full map. So you can see the full map of the hub. Do you understand what I'm saying? Yeah, so with that, so with ROS, it means you can do your things like autonomous navigation, map your environment, go and map your office, you understand, your offices, your classes, do those things, tune your robot, and build, robots that does something. Do you understand? So this thing is possible in Nigeria. Do you understand? Yes, it's possible. It's possible. We have the framework. We have tools, and that's what. And I think that is basically all for the meetup. Sorry for the presentation. Yeah, thank you. I'm Samuel once again. I'm founder of RoboCreate, and would like in case you are interested, is that time? Okay. They're going to put it up. Okay, but in case you are interested in some of all these, the kits and some of the hardware that we have on ground to help you get started with ROS, and even some of the softwares or the simulation files that you can get started with some of all these things, you can reach out to me. You can reach out to my co-founder here. His name is Yusuf Bello. Reach out to us. Yeah, thank you. Oh, so
good afternoon, everyone. It's very, very nice to have all of you here. My name is Yusuf Bello. I'm the Chief Operating Officer of RoboCreate. So I'd like to point out something real quick. You saw the demo of the robot we did here. If you'd like to get into it, like he said, we've done a lot of work towards making robotics easier to learn in Nigeria and Africa, basically, or the world included. So these models you see here, they are readily available with us, and we've kind of simplified learning of robotics. If you want to inquire about any of them, you could reach out to me after or even now. I'm totally open to explain and see how I can give you access to them. We're actually giving out some for free, so you just walk around it, have a fun on robotics, and then you don't have to also use it just for this project. You can use it for multi-project from robot arms. Basically, whatever project that has to do with precise control, this would give you the precise control. What we are normally used to is the L293D. You just tweak with PWM, right? So you could see the movement he was given. That was precise control, so which is what we actually got in for with the EPMC model you're seeing here. The easy IMU, it has to do with basically IMU readings, right? If you want to build a drone, if you want to build a balancing robot, we have you covered. So if you have any questions or anything you'd like to, please reach out to us. We'll also drop our link on the Zoom chat, so you could reach out to us, our email too. You can find them here too. Thank you very much. The clap should be for email. It's not that different.
So thank you. That's all for the presentation. I think, is there any questions or? I don't know if there's any on the chat.
Questions for presenters, Samuel. Okay, we have a question here.
Good afternoon. Thank you for your talk. I'm actually very interested in this particular topic because my final project involved trying to build something, even though a much simplified version of this in Mina. So once I saw this, I was so happy because TurtleBot, Aurora, the different robotics platforms, they are out of range of Nigerians most times. So we had to look for how we make our own. So I'm so happy that something like this has come out, and we have seen it in the ROS Naija conference. So my question for you is, what's the minimum viable? Is this the minimum viable platform for doing navigation, autonomous navigation? Is there any way to scale this down further? Is it possible to do this with a monocular camera, with stereo camera, without the LiDAR? How low can we get to make it more accessible to Nigerians?
Yeah. So thank you for the question. Like I said, navigation generally, depending on what you want to achieve actually, it's possible to go lower. For example, if I decide to maybe stick with only just using camera, I may not be able to achieve what you see, what you just see now. Do you understand what I'm saying? So that's why it all depends on what you want to do. That's why you notice I showed a different example of one that uses a predefined path, like a line follower, but interconnected load. That's, for example, that's more cheaper, similar to like doing all those Amazon robotics or something. So it depends on what you want to achieve, what you are looking at. But if you are looking at something of maybe 2D navigation, you want to do all this, you have to buy LiDAR. That's where all this is. Do you get what I'm saying now? Yes, you can also now you can also, for example, now I know I told you about the mini version, which I told you about a mini version. You understand? I'm like ESP32. We started integrating with ESP32 because of things like this. Do you understand now? Where you can also do some of your basic ROS tags, even Python, OpenCV, and AI live coding and things like that. So we have that. If the LiDAR or some of the things maybe are scared that maybe might not be able to afford it or things like that. So there's a mini version, but like I said, it depends on your tax. The major thing is, what do you want to achieve? So going low will mean if I should, like I already explained that once I remove this LiDAR, everything I'm doing here, I cannot do it again. Do you get what I just said? So it depends on what you want to achieve. Then you can now formulate maybe your own type of problem statement around it and see possible sensors you may be able to use to achieve that. Yeah.
Okay, yeah. The reason why I was asking is because, final projects are very expensive. So buying this platform, how much does it cost? That's the main question I have.
Okay, currently, because of some of the new add-ons.
So currently, like we said, this can be scaled up, basically, up to university level. And we are very, very much aware that you said access to Nigerians. I believe you are saying it price-wise, right? So we are looking at bringing it very, very low currently. And are you done with the final project?
Yes, I graduated 2024.
Right.
Yeah.
Congratulations.
Thank you very much. It was easy.
I can tell. So we are looking at actually bringing it down to university levels, and we are still on the price review such that it will be affordable to every individuals that require, not just university level people, like very, very affordable. So you can just keep up with us on our website. We'll be revealing those informations very, very soon. We currently have a kit that they can work with, but the localization, SLAM and everything is not, yes, but there's a camera interface though. You can integrate OpenCV with it. Then from there, instead of that, you do something less, and it's way cheaper, like way, way cheaper.
No, they can command it from there. Just, you know how to command it now. Command it anywhere you like. Yeah, I'll just be. Okay, so I'll be rounding off now. So he wants to give it a command. So don't bring it to this side, though. Don't bring it here, please.
All right. I have a question. My question is from the previous person. I think that was the previous person that gave a talk, right? I asked how do we deploy ROS into hardware. So he said that I should relate the question to you. So I'm now doing that. Like you are done with simulation and you want to deploy your simulation, your code from your simulation to a hardware. How do you go about it, sir?
Yeah, that's a nice question. Yeah, so basically, once you are going from simulation, you have to now look at a different part of your code. For example, when you are simulating, if you are using ROS to simulate, you probably will have your robot, what they call your robot description. Just take note of all those things. If you don't even if you don't understand it now, but take note of it, you'll be hearing it. Even if you check someone else's robots, you will see what some of these things I'm saying. So you have what they call your robot description. Remember the previous presenter mentioned something about URDF. So normally you will have that. Do you understand now? And if you notice, he also mentioned something called ROS2 control. You remember? So those two are very key. Do you understand now? When you are integrating your simulation to your hardware. Now I also want to explain something. There's what you are seeing here now this is not simulation. This is what? Visualization. Simulation is done on maybe the gazebo, Isaac sim, whatever. All these are just, I'm visualizing sensor data. That's what I'm doing. Do you understand now? So mostly you'll be doing more visualization and be working with your actual code, just the way I'm doing it now. So basically, you need to know how to integrate ROS2 control with your code. And for ROS2 control, you require hardwares. And there are two ways to go about it. Is either you get an hardware that they have built the hardware driver. Just where you buy Servo Moto and you download the library from Adafruit. Do you understand what I'm saying? And so most companies that build hardwares build their drivers, ROS drivers for it. So that is what you integrate with your URDF. You understand now? And use maybe the ROS2 control library to call it and start controlling your robot. So what we did at RoboCreate was to create an hardware. We are all used to motor drivers. You just plug your motors, and there's the drivers. The ROS driver is already available, or the ROS plugin. So all you need to do is, and we have example files for how you can use it, integrate it with your robot. Do you understand? Whether you are using a 2-wheel, 4-wheel, Mecanum drive, talk about it. Do you understand what I'm saying? So is that process of integrating ROS2 control with your description file? That is where the real work is. But if you have with the right hardware, you can do that. Do you understand what I'm saying? Did I answer your question?
Okay. So you talk about hardware. I've made my research on that aspect, and I want to get better understanding on it. Arduino, Raspberry Pi, and then ESP32, right? I know that Arduino are much cheaper than Raspberry, and then we also have ESP32, that is much cheaper than all. So I want to ask, can one deploy ROS2 into ESP32?
Yes, you can deploy ROS on ESP32. There's a lower end ROS called micro ROS.
Okay, micro ROS.
Just like ROS for embedded system. Do you understand? So you can actually deploy ROS on ESP32. Now, for that, there's another way we will do it at in RoboCreate. Okay. Because a lot of the things you see here, the motor controller works with what? It's a kind of ESP32 controller. Do you understand now? So there's a way we do it, not the micro ROS style, but it's a new style we worked on it. That's how we want to develop this control system and make it easy for me.
Okay, so your kit has an ESP32 embedded on.
Yes.
Okay.
Yes. So that I'm just saying that it's possible to deploy ROS on embedded, but it's not that ROS is like Python.
Okay.
That Python is designed for your PC.
Yeah.
But we have MicroPython.
Yeah, from embedded systems.
Embedded. Do you get it? That's exactly how that micro ROS is. ROS is designed for PC level something, but micro ROS can now deploy it on what?
On embedded systems.
So it's possible, yeah.
All right, thank you.
Let's appreciate Samuel for that wonderful presentation and demo. Thank you very much. Those of you online, apologies for not being able to actually see a lot of the live demo, but I'm sure you can see the map we've been able to build of this hall. In the map there, you can see some sky blue dots. Those are like chairs and people. You can see the red dots. Those are called, this is our cost map. So the red dots are part of the cost map, and the blue lines just shows the different parts that the robot has considered taking, and it eventually takes one of those parts to its goal point. Then during his presentation, he showed you a page with those two distributions where you were seeing things like Harmony, Foxy, Jazzy, and all of that. I'm surprised nobody asked, why ROS 2? What about ROS 1? Nobody asked that question. And does anyone have the answer to that? Why are we talking about ROS 2 and not ROS 1? Okay, thank you. ROS 1 is in the past. It's just the way you have Windows 7, 8, 9, 10, 11. That's how you also have ROS 1 and ROS 2. And for ROS 2, you have different distributions. Instead of us giving numbers like Windows 10.1, 10.2, 10.3, in ROS you talk about names like Harmony, Jazzy, and a lot of what you've seen there. So ROS is a very interesting abstraction or middleware layer. Like I said, it's not an operating system. It just connects a lot of all these things for you. With ROS, you can easily plug and play, take in and take out. You can connect almost any hardware to your robot. It helps you control it. And aside from that, it also makes it easy for deployment. If someone has already done, let's say, a package, or as most of us are used to, a library to work with something, you just download it and you plug it into your system. It works. And you don't tell me that because my camera has stopped working on this robot, that this robot cannot map. It will still keep working. It's not like a lot of our programs that when one aspect spoils, the entire stuff breaks. So that's basically it. Now, at this section, I would like to call on our game master, Nathaniel, for the game section of this. So for those of you online, you're going to miss a lot. It's just so sad. But for those of you here, you can come and look at our robots and also participate in the games. So thank you very much. And we're very glad that you could join us for this pioneer edition of the ROS Naija Meetup in Abuja, the capital city of Nigeria. Do enjoy the rest of your evening. Okay, yeah, this is still going to be streamed, so you can still enjoy this online. And at the end of the day, we'll be having a group photograph and okay, oh, and please, there's refreshments for everyone here, so before you leave, make sure you receive yours. Thank you very much.
Okay, so I'm sure we've closed officially. So just a demonstration with our SO robotic arm, teleoperation, basically. So for those that are interested, I just want, if you can use this to stack up these Jenga pieces we have here. And let's see how high you can take them. So anybody interested, you can come and try it here. So Okay. It has 6 degrees of freedom, so you can move as far to any angle. Okay, let's see who will beat that today. Okay. But I just want to know, I don't think 6 is redundant, because that is as much as our hands have. Okay. But there are some angles that this can reach any angle within its space. Really? Okay, yes, that's a very good question. In which plane? Because if you're talking of, sorry, please, how many did you do?
Is anyone keeping count? About 5. You did 5. How many did you do?
You did 6. Okay, you can go on. Just reset the hand.
So for our leaderboards, the first participant stacked 6, while the second stacked 5. Let's see if anyone can beat those records. What's the prize? Well, if I tell you the prize, you might not be so motivated. And at the same time, if I tell you the prize, if you might be over motivated. So win it first. Win it.
Well, is it meant to? You don't have to stop.
Excuse me, sorry.
No, he's
Sorry. You can actually move this far. Is it better now? Take it, continue. Okay?
So don't forget, take advantage of this opportunity, interact, network, connect, talk with people, know what they've done, what you are interested in, what they are interested in, what you can do together.
Is it safe to say you're only able to stack one?
I think there should be a timer.
At this point, I'm giving up.
We would have somebody going out through the day.
Yep, 2. Well, they say slow and steady wins the race. Let's see if that works here.
Maybe. It's not in it.
Yeah.
Slow and steady. Take the robot arm off.
I'm really rooting for you.
On the contrary, I'm not.
No, I want to share the prize with him. That's why. I hope a lady goes next. The ladies have been too quiet. Are you going next? Yeah, all right. That's good. We have a tie for the second place on our leaderboard. We are going for the first place. Well, you can still go on. It hasn't yet fallen.
Go for the one outward now, the outside ones.
At once? Yeah, definitely. You can stack. No. Just one. Okay. Yes. Okay, we have a tie for first place. Yes. Like I said, I'm rooting for you. No, go ahead.
I think for now we're going with the 2 minutes timer. Because 1 minute timer.
Can you move the...
And for 1 minute timer, we'll set to that board. Alright, so you have 30 seconds now.
Don't settle for a tie. Go for the win. Don't settle. Remember what one of our presenters said, just do it. You have nothing to lose.
Not to pressure you, but you have 5 seconds.
Come on, anyhow, just put it. If it falls, if it stays, you have nothing to lose.
Yes.
Thank you. Go ahead. Oh, your time is up. Let it be on record that I had his back from day one. I can see a lot of doubters are not happy. They are just clapping and smiling, but they are not happy. Thank you. Okay, a lady next.
I don't use the timer.
Okay. No, for how whole 1 minute 13 seconds. No, we'll reset the leaderboard.
Okay, I have some good news and some bad news. Which one do you want first, the good news or the bad news?
The bad news.
The bad news is that the leaderboard has been... We are now going with a timer, and the good news is that everyone has a chance to be the winner now. So, let's see. She has 1 minute and 4 seconds to win it. Yes. Wow, that's very smart. Yes, that's a hack. Hey. So the ladies have been hiding themselves, Abby.
Open the gripper now. You have to let the gripper open.
Okay, use your thumb, ladies. Push it out with your thumb. Yeah. Oh, okay, go ahead. You have 5 seconds. 4, 3, 2, 1. Your time is up. So we have someone that's leading. First position goes to her so far. So who is next? Anyone willing to challenge? All right.
Nice.
You can try again.
Not yet.
Nice.
All right, your time starts. Are you ready? Okay. Okay, so this is not part of it for you. Are you ready?
Yeah.
Your time starts now. 2. Good, good, good. That was fast.
Slow and steady, they say, win the race.
Who cares about slow and steady when you have quick and swift? Don't mind me. Slow and steady also wins the race.
With the timer behind.
Okay. We have a new. Wow. That's a new record. 4 stacks in 40 seconds. Wow, 5 stacks in 50 seconds. Less than 50 seconds, 5 stacks. Okay. No, you're not allowed. You can't move that particular tile.
You can. It has a twist. You can turn the neck.
Yes. Oh, okay. We have a.
The advantage of sitting there.
Yeah. Bob the Builder. Can we build it?
He is actually a gamer.
We have 6. Oh my. So where's Yusuf? Your record is being shattered in record time. 5, 4. Oh! So we had 6 tiles, right? Yeah, that's fantastic. So we have a new first place. Okay. Anyone?
You don't want to?
Anyone want to try? Anyone else?
Let me try and beat it.
You don't take notes. Do you have Ovodo? Do you have beer? Thank you. The accent. Okay. Where's the timer? Okay, you have wow, that's good. 3 tiles in less than 20 seconds. 4 in less than 30 seconds. Good.
No, they are familiar with all the controls. That's why.
5. No, he's an unofficial contestant, so don't worry. 6. 40 seconds left, and he has 6 tiles already. Okay. So like I said, connect, interact, network. Wow, that's 1, 2, 3, 4, 5, 6, 7 tiles in 1 minute and 10 seconds. Wow, 8 tiles in 80 seconds. 9 tiles in less than 90 seconds. 3, 2, your time is up. Thank you. So he's unofficial, so he's not going to be on the leaderboard, don't worry. So the record to beat is 6. Wait, is it 6 or 5? 6? Okay, the record to beat is 6. Okay, go ahead. Are you ready? Okay, please pause. No, he has not started. Start. I hope we've really learned a lot about ROS today. So if you want to know more about ROS, you can go and look at the official documentation for ROS. ROS is a well-documented platform, so just go to ros.org. The tutorials are there, videos, blogs, everything you need is out there. Yeah, you can go on YouTube and search those 2 tutorials. There are a lot of them out there. You can look for RoboConstruct on YouTube. You can look for RoboGeddon, on YouTube. You can look for articulated robotics on YouTube too. They are very helpful resources. There's a lot of them out there. Okay, we have 6 tiles. 6? Yes, in 70 seconds. You have 15 seconds more. 7 tiles. You have 8 seconds more. 8 tiles. Very neat, I must add. Oh, your time is up. 8. Thank you. Thank you. Let me try. No, no. This is an unofficial leaderboard. So is anyone timing me or I am? No. I've started, by the way. All my tiles are. How do I turn these tiles? That worked. I'm actually not bad at this.
Yeah, even holding the mic. That's a new.
Maybe
Thank you.
practice.
1, 2, 3, 4, 5, 6. You don't go.